Okay, so in this lesson, we're going to be looking at scientific notation again, and we are also going to look at what happens when we get a negative exponent or an exponent that has a value of 0. So before we do that, I just want to kind of follow through in terms of the pattern that's happening here. So we have 16 decreasing to 8, decreasing to 4, decreasing to 2, decreasing to 1. So if I'm following this, it's going down by half each time. So that would be 1/2, 1/4, 1/8, so on and so forth. So if I write this as exponents, this is 2 to the power of 4, 2 to the power of 3, 2 to the power of 2, 2 to the power of 1. I'm going to skip 1 for a second. I'm going to tell you now that this is 2 to the negative 1. Oops. This is 2 to the negative 2, and this is going to be 2 to the negative 3. So what number is missing here? We have 2 to the power of 0. So let's kind of talk about where that 0 is coming from, okay? So on your handout, you have a box that's called exponent 0. So any base to the exponent 0 is always going to have a value of 1. So in that box where it says exponent 0, so if I were to do 2 to the 3 over 2 to the 3, I know that 2 to the power of 3 is 8. 2 to the power of 3 is 8. Any number divided by itself is 1. We also know from our exponent rules that if we have the same base, we can subtract our exponents. So 2 to the 3 over 2 to the 3, so we're dividing, I get 2 to the power of 0. I just indicated that we get a value of 1. So make sure you write any base to the exponent 0 equals 1. So in the box that says examples, let's look at some. So if I have 5, that's negative to the power of 0, I get a value of 1. If I have negative 1,000 x squared y to the 97, and the whole thing is to the power of 0, guess what? It has a value of 1. The only tricky thing is that sometimes if the negative is not inside the bracket, we get negative 1. In this case, because the 3 to the 0 is 1, so this part right here, so the 3 to the 0, this part is 1, but then that negative is still there. Now, negative exponents, they generally mean that we will have a fraction. I'm a little hesitant in putting that there, but it just means that our denominator is bigger than our numerator. So if I have an example where I have x to the 3 over x to the 5, if I write this out the long way, so I have 3 x's on top, 5 x's on the bottom, I'm left with 1 over xx, which equals 1 over x squared, which is the same as x to the negative 2. So if you'll notice here, 1 over x to the 2, if I use my exponent rules, I would have done 3, take away 5 to get negative 2. So the rule that we have is that x to the negative n, whatever that is the same as 1 over x to the n. Or if I have 1 over x to the negative n, that's the same thing as x to the n. So essentially we're flipping it. We're finding what the reciprocal is going to be to switch from being positive to negative. So some examples of how this is going to work. Actually, just let me raise this up. So for examples, if I have 5 to the negative 2, that's the same thing as having 1 over 5 to the positive 2, which is going to be 1 over 25. Now, if you do this on your calculator, you're going to get 0.04, I believe, is the value that you're going to end up with. Oftentimes, we want to keep it in exact format, so 1 over 25 is a better answer. Another example would be 2 over 5. If I have that to the power of negative 2, to make it positive, I'm going to get the reciprocal. So I have 5 over 2 squared. And then when I evaluate that, I square the numerator to get 25. And then, I square the denominator, which is going to be 4. And I'm going to leave that. So let's look at a few more examples of this. So the first example, I would have 2 to the 4 over 2 to the 6. So if I use my exponent rules, I'm going to subtract. So I get 2 to the negative 2. But I might say, make sure your exponents are positive. So then I'd be expecting you to do one step further and make it 2 squared in the denominator. Now, some of you might notice that the denominator in this case is bigger. So because the denominator has a bigger value, then the base has to stay in the denominator. But either way, that would be your final answer, which would be 1 over 2 squared. Now, I guess we could do one more here and write this as 1 over 4. If you do 2 to the negative 2 on your calculator, you're going to get 0.25. But we want our answers to be fractions. Okay? All right, so now this one. So I'm working this out. So I have common bases. So x to the 4, I got my silent 1 here. So that's going to be x to the 3. Then y to the 3 over y to the 3, that's y to the 0, which is just going to be x to the 3 because y to the 0 has a value of 1. I don't have any y's, so I don't write it anymore. Okay. So now in this example, I have 2 to the 4 divided by 2 to the 2, so I get 2. I have x squared divided by x to the 1 to give me x. And then I'm going to have y to the negative 6. So I actually have another step here because I don't want there to be any negative exponents. So I'm going to have 2 to the 2 is 4. That x is going to stay there. And then I'm going to move that y to the negative 6 to the denominator. And that's the only one that I'm going to move because that's the only part that is negative. Okay, so let's look at this example. So lots of things going on here, so I'm going to do it step by step. So in the numerator, there's two different things. There's this 4m squared, and then we have this bracket. So my 4m squared, nothing is happening. But then I have my cubed out here. So that's going to impact everything inside. So I'm going to have 4 to the power of 3, n to the power of 6, m to the power of 9. And then on the bottom, that 4 is going to impact all three terms. So I'm going to get m to the 4, 4 to the 8, and n to the 12. So this is pretty messy and hard to look at. So now I'm going to put everything together. So don't forget that this 4 right here has a little 1. So I see that I have 4 to the 1 and 4 to the 3, so that's going to give me 4 to the 4. I have m to the 2 and m to the 9, so that's going to be m to the 11. And then the n is all by itself, so that's just going to stay as n to the 6. And then that is going to be over. I'm going to move that 4 out in front here, so 4 to the 8, m to the 4, n to the 12. So now I can use my common base rules. So I have 4 to the negative 4, m to the 7, and n to the negative 6. So when I see that, I'm like, oh, wait a minute. I have two terms that are negative. So I'm going to need to make those positive. So this is going to equal m to the 7 over 4 to the 4 and n to the 6. So that's as far as we're able to go there. If you want to change the 4 to a value, you can, but in this case, we're just simplifying, so keeping it as 4 to the power of 4 is totally fine. So that's kind of looking at how to deal with zero exponents and negative exponents. So we've seen this table before, way back when we were looking at scientific notation. And when we had scientific notation, we had exponents that were negative, but we didn't really explain too much why they were negative, other than if they were negative, it was really small. If it was positive, it was a number that was getting bigger and bigger and bigger. So in this case, these exponents are negative. So I can rewrite 0.1 as 1 over 10. 0.01 would be 1 over 10 squared. So that negative exponent that we just introduced still applies right here. So let's look at some scientific notation. So had I been in class, we probably would have done this activity up at the whiteboards, but since I'm not there, we're going to kind of do a couple of these together. So I haven't included all of these examples on your handout, but I did include a couple of them. So to remember, to put them in scientific notation. So scientific notation means we're going to have a number with a decimal times 10 to a certain power. So I start all the way at the back and I move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is going to be 1.2 times 10 to the power of 11. Now the B example, it's a really small number. So instead of going to the left, I'm going to the right. So 1, 2, 3, 4, 5, 6, 7, 8. So this one is going to be 4.03 times 10 to the negative 8. So I personally find it a little bit easier to take a number and put it into scientific notation because I'm just moving the decimal until I hit that first number. Okay, or when I'm going to the left until I get so that there's only one number after it. Okay, so I'm going to leave letter C and D for you to have a look at. In example 2, we want to write them in numeral notation, so actually the full-on out. So the way that I do it is I see, okay, I have 4. I know my exponent is 7, so it needs to move 7 places. So what I start is I write down the 4, and then I start counting and writing down numbers that I know. So I have 4 point, but I'm not going to write the point anymore. I have 9, which is 1, 2 places is the second, and then I need 5 more zeros. 2, 3, 4, 5. So then if I were to check it, 1, 2, 3, 4, 5, 6, 7, it works. So once I get my answer, I always want to check to make sure that it works. So I'm just going to, get rid of all of those things. Now this one is a little bit harder, but again, because it's -5, that means that I am going to have 5 numbers between the decimal point and the first digit. So I'm going to have 0.1, 2, 3, 4, and then I'm going to put 608. So when I look at that decimal, it's going to go 1, 2, 3, 4, 5. I checked it. I'm good to go. Okay, so you can try those other 2 examples. So you're probably sitting there wondering, well, why are we just reviewing this? What's different now? So now we're actually going to look at how scientific notation can use exponent rules. So we have 4 examples here. So we are going to look at what's happening. So when I'm multiplying, I have 1.08 times 10 to the -3 multiplied by 9.3 times 10 to the -3. So I'm going to put my numbers with numbers and my powers of 10 together. So I'm just rewriting it in a different order. Okay, so I'm going to use my calculator and I'm going to multiply 1.08 times 9.3, and that's going to give me 10.044 times, both of these are base 10, and I'm multiplying. So I can add my exponents together. So I get times 10 to the negative 6. But that's not true scientific notation because I have 2 digits before the decimal. So I need to change that. So it'll be 1.0044 times 10 to the negative 5. I'm going to do example 3 next. So same idea. I'm going to I'm going to divide 7.1 and 8.2. And on my calculator, I'm going to get 0.87 times 6 minus 1 is 5. And then I want it to be in true scientific notation, so I need to move that decimal place. So I'm going to have 8.7 times 10 to the 4. So why don't you pause the video, take a minute, and try the next two. I realize on your paper, the third example there's a little bit of a typo, so you can scratch that out and we'll fix it. So hopefully you've paused it and tried it. So I'm going to have 2 times 8.1 times 10 to the negative 4 times 10 to the negative 1. So I get 16.2 times 10 to the negative 5 because I'm adding those exponents together. But again, it's not in full scientific notation. So I have to move that decimal place. So I get 1.62 times 10 to the negative 4. Okay, I find the division ones are sometimes a little bit easier, but again, because I don't have to rewrite it more than anything. So I have 5.4. As I mentioned, you cross out what's on your paper and change it to this example. So 5.4 divided by 3.4, I'm going to get 1.588 times. So in this case, I have 10 to the negative 1. I'm dividing, so I subtract. So I get 10 to the negative 2 as my answer. And because I only have one digit out in front, I don't need to go any further. So you'll notice down at the bottom of your page, there's a little section that says summary. So that's meant for you to write some notes to yourself about different things that happened in this video. See you next week.